Hello and welcome back. Next, we're going to look at the number object and the math helper object or utility class. JavaScript only has one type of number, and most people think that this is the correct answer. You should only have one type of number object inside of a programming language. Most have several. They have integers, they have floating point numbers, they have big decimal. JavaScript only has one. The downside is JavaScript chose the wrong type of number to have. So here's the basic example of what went wrong. 0.1 plus 0.2 equals 0.3. And the answer is that's false. That has to do with the fact that the number type they chose, the floating point, is highly imprecise, so it's bad at performing mathematical operations. Now to compound that problem, they, instead of having the methods in the math class be attached to the number object, they created a separate math class to do this. So many people think that the number object is the worst piece about JavaScript. So inside the code, I'm on number and math right here inside chapter 1, and I'm throwing a debugger after the first it statement. So the describe statement say what's going to happen, and then it jumps us off. So the first thing we're going to look at is what is known as precision values. And precision values are basically how many digits or how many numbers do you have after the zeros. So for example, I have two numbers, and if I have a zero-based number, and I say I want 2 precision on it, then that means I want 0, 0, and then the 1 and the 1. Those are two significant digits. If I do the same thing to precision level 3, here I'm asking for it to have 3 significant digits, and it starts with 1, so 1, 2, 3, and that's the value that I'm going to get is 1.36. So pretty simple stuff, and then 2 on that same number would be 1.4, and it's going to round up on the 3.6, or 0.36. So we'll see that is the answer, and you'll see and also notice that this converts it into a string, and that's very important because now if you were to return this value back without converting it and try to add it, now you're going to get the problem of adding a string to a number. Next, we have the fixed decimal places. This is very common because when you perform most math operations in programming, you'll end up with 7 or 8 trailing digits, and generally you only want to show the users 1 or 2. So this will allow you to do that. So we take the value 1.3422, and then we say we only want that number to be fixed to the second position, and now we get 1.34 back. It should come as no surprise that you can add numbers. So if we take a variable 1 and a variable 2 and we add them together, we're going to get 3. Hopefully that one does not surprise anyone. Likewise, we can perform addition, multiplication. So here, 1 divided by 2 is 0.5, and 2 times 2 is 4. Next is something that you may not have seen before unless you're used to programming, but there's something called the modulus operator, which is a fancy name for remainder. So if you take 3 and divide it by 2, what is your remainder? Well, the remainder there is going to be 1. And we can see that right here. Next is the example that I showed you that JavaScript is very bad at dealing with precise numbers. So when we take 0.1 plus 0.2, you can see the number that it actually gives you is 0.300004. So it can't quite round it correctly. And because of that, we get that 0.1 plus 0.2 does not equal 0.3. And that's the reason why the 2 fixed and several other operations are necessary. Next, we can explicitly coerce a number using number, parse int, or float. So if I have the string 1 and I call the static number function on it, I get 1. If I call parse int, I'm going to get 1. Notice the second argument, parse int, allows you to convert to decimal or other bases. So it is considered best practice to put 10 there, even though in ECMAScript 5 it is now specified that the default argument should be 10 if it's not listed. And then finally there is parse float, which will just convert to a floating point number. Parse int will truncate it if it has any decimals. So of course we get 1, 1, and 1 as our operations. Next we're going to look at the math class. So the math class allows us to raise something to the power, and what most programs would expect is that you should be able to do this. Say 3.power is 2, but that doesn't work because they carry this weird math class. So now I have to call math. You can see here all the stuff that's on the math object. Say it, I want to raise to the power 3 to the power of 2, and I expect that to be 9. And then floor, this will throw away all of the trailing digits. So everything in the fractional remains are going to be removed. So whenever I call that, my result is 3. This is something else you see a lot in JavaScript to remove the imprecision of having decimal places. People will just simply throw it all away. Ceiling does pretty much the same thing except for it raises it. So even if I had 3.001 and I called ceiling on it, it would immediately raise that to 4. Next, there is what's known as the shorthand operations. And we start off with A and we set it equal to 0. And I'm going to pull this up because this is sort of important to see. So the first is what's known as plus plus. Plus plus means increment by 1. That's where C++, the joke is. It's saying it's like the C language, but plus plus, it's 1 better. So now A is going to be equal to 1 minus, or plus equal 1 is equivalent to doing plus plus. I prefer using this syntax because plus plus only works on one thing, whereas plus equal you can do 2, 3, 4, whatever. And I think it's a little more clear what's going to happen here. And some languages like Python I don't think Python has a plus plus operator in it, so it doesn't really matter. But I don't like it, but you're going to see it a lot in a lot of code. So minus minus, that means decrement by 1, so now it was 2, now it's going to be 1. Minus equals does the same thing, so now we're back down to 0. Now we're going to use the plus equal, but now we can set that equal to 3, so A is now 3. Times equal means take the value of A, multiply it by 3, so that's the same thing as saying A equals A times 3, that's going to be 9, and then divide equal is the same as saying A equals A divided by 3. So now we're going to get 9. And then finally, you can perform mathematical comparisons. So 4 is less than 5, that's true. 5 is greater than 4, that's true. 5 equals 5, that's true in both cases. And 4 is less than or equal to 5 is true. And 5 is greater than or equal to 5 is true. So you can perform basic mathematical comparisons, and this gives you a Boolean result, which is what we're going to be looking up pretty soon. So that explains everything there is to know about numbers and math. Obviously, there's a ton of other operations, but these are the ones you're going to see most often. And generally, what you're going to be doing with math inside of JavaScript, because of the high level imprecision, is you're going to be truncating numbers. You're going to be rounding down. You're going to be limiting the precision, or you're going to be converting to certain bases.